Voting Theory Class 10 Video 2. In this video we're going to talk about a different fairness principle. We're going to talk about the Condorcet loser fairness principle. But first thing, we need to talk about what a Condorcet loser actually is. So a Condorcet loser is like the symmetric dual to a Condorcet winner. Remember, a Condorcet winner is an alternative that beats every other alternative in a head-to-head runoff. A Condorcet loser is an alternative that loses every possible head-to-head runoff. And exactly analogous to the Condorcet winner, Condorcet losers don't always exist. Sometimes they exist and sometimes they don't exist, okay? So not every voting profile has a Condorcet loser, but sometimes they do. So it's an alternative that loses every head-to-head match. And what is the Condorcet loser criteria? So a voting system satisfies the Condorcet loser criteria if the winner is never a Condorcet loser, okay? So pay special attention to precisely what this definition is saying. It's not saying that the Condorcet loser has to be in last place. It's just saying that the Condorcet loser cannot be in first place. So if the Condorcet loser is in second place or third place, that's perfectly fine. But you should never have the Condorcet loser in first place, which makes sense because, you know, by definition, the Condorcet loser is an alternative that would lose head-to-head with every other alternative. So it's undesirable that someone like that would win get the highest place in the social ranking. But like a lot of the fairness principles, they're actually quite hard to satisfy. So for example, if we look at this voting profile right here, okay, and the voting system is the plurality voting system. So the social ranking is easy enough. It's just A, B, C. Okay, this is the social ranking because A has 40, B has 31, C has 29 top preference votes. But let's see if there's a Condorcet loser. So if we consider the head-to-head A versus B, A is going to get 40, just 40, and B is going to get 31 plus 29, which is 60. So B wins. If we consider B versus C, B is going to get 40 plus 31, which is 71, and C is just going to get 29. So B wins. And finally, if we consider A versus C, A is going to get just 40, and C is going to get 31 plus 29, which is 60. So C wins. Or more importantly, A loses. If you consider A versus B and A versus C, we see that A loses in both head-to-head runoffs. So this means that A is the Condorcet loser. Okay, A is the Condorcet loser, but A comes in first place under the plurality voting system. Okay, so even though A would lose every head-to-head runoff, A would lose if it went head-to-head against B, and if it went head-to-head against C, it still comes in first place overall under the plurality voting system. So what does this mean? This means that the plurality does not satisfy the Condorcet loser criteria. Okay, so the plurality does not satisfy the Condorcet loser criteria. And this example shows that. So what voting systems do satisfy the Condorcet loser criteria? Well, I can write a small theorem. Okay, and it's just any voting system that requires an alternative to go head-to-head in the final round. In a final round satisfies the Condorcet loser criteria. Okay, and this is because if your voting system requires a head-to-head in the final round, then if there's a Condorcet loser, it will always lose that head-to-head, so it will never be in first place. So in particular, stuff like instant runoff, two-round runoff, Baldwin, agenda, they all satisfy the Condorcet loser criteria. Okay, they all satisfy the Condorcet loser criteria. So that's the end of this video.